Let's talk about channels. These are very important for how Photoshop displays what you see on your monitor. Now, there's a channel palette. We can get to that just by going to Window, Channels, and that will pop right up. And it has some things going on. The question is, where did all of this come from and what's happening here? Well, this is actually controlled under your Image menu and under Mode. You can see right now we're in RGB color mode, which means that in our Channels palette we'll have RGB, which is our composite, and that's made out of red, green, and blue. It's possible to use other modes, such as CMYK, and odds are, if you've done any printing in Photoshop, people would have recommended that to you. That stands for cyan, magenta, yellow, and black, the 4 colors that a standard printer would have. There are other modes, such as lab and multi-channel, index color, and grayscale. We'll talk a little bit about a few of those modes later in the semester, but for now let's go ahead and concentrate on RGB. So RGB has the 3 channels and the composite channel for the 4 that display in your channel palette. What does it really mean? Well, there's a secret here that we need to delve into a little bit further. Underneath mode, you can see that we also have bits per channel. So, okay, that doesn't really fit in just yet, so let's cover that a little bit more. First, what is a bit? A bit is a binary digit. It's a way of saying, hey, this thing only has 2 possible states, on or off. Let me give you an example. The classic example is a light bulb. So let's go with the classics. You could have your switch down and your light bulb would be off, or you can flip your switch up and your light bulb would turn on. That means that you have 2 possible states for a light bulb, off or on, off or on. So let's go ahead and talk about the math for a second. Math, I know. Oh, math. That's okay. The cool thing about Photoshop is that the math will actually be handled by Photoshop. You just have to have a kind of general understanding about what Photoshop's doing so that you can have better control over Photoshop. You don't have to sit down there with the calculator and crunch the numbers. Photoshop will do it for you. So let's look a little bit at this. So let's say we have a bit. Okay, I've made this bit kind of look like a light switch. It has 2 different ways of being. You can have it flipped up for on or flipped down for off. On, off, just like a light switch, right? Well, we're going to represent that with on being 1 or off being 0. All right, so pretty neat. What's that mean? Well, we can have more than one of those. So we had the light bulb that was on or off, right? Which is great. You know, we could come in here and be like off, on, sweet. So we've got that represented. Well, what if we went something a little more complicated? You know, some light bulbs have those cool fader switches. And so you could come in there and you could be like, oh, I want it fully on. I want it, you know, a little bit on, not entirely on. So I'll go in with that fader switch and I'll just kind of fade that and have a nice kind of dim lighting or have the full lighting. Well, we want Photoshop to be able to do that, right? Because if we only had one setting, you know, on or off, like what would that really mean? That would mean that we have on or off. We'd only have, you know, everything or nothing. That's not great. That's not what we want. We want colors. We want shades going in. We want to be able to go in with that and say, hey, I want to have like 50%. I want to have 100%, 75%, all that stuff. So how do we do that? Well, we use more than 1 bit. So if we had 2 bits, suddenly we have more options available to us. With 2 bits, we could have different states. For example, we could have everything on, like 100% brightness, or we could have one of them on, one of them off, and you know, that would be like 50% brightness all of a sudden. I would come in here like, oh, hey, 50% brightness. Wow, what's going on there? So that's kind of cool, right? And then you could have both of them off, and then that would just be, you know, completely black again. You'd have the blackness going on. Ignore these squares. That has to do with the presentation. That's just to let you know. So we have 4 different possible states going on here. 2 of them produce the same result, but in computers, they are different. So let's look at that for just a second. We can have both on. We could have the first one off, the second one on. That's 2 states here. We could have the third state would be them both off. And then we could have first one on, the second one off. That's the 4th state. So we have 4 states. Okay. Well, what if we had like 2 bits? That's easy to figure out. But what if we had like a whole bunch of bits with different states? Like how many possible combinations, if we were flipping these up and down, do we have? Mathematicians figured that out for us. So they actually use a formula here where they take 2 to the power of however many you have. That's about it. It's an exponential function. So let's think about that for just a second. I've got a calculator right here. If we have image and mode, and we've set our mode to 8 bits per channel, well, how many states do we have? How far can we go up and down between off, where everything's 0, or on, where everything is just maxed out? It's all white, right? It's all coming on. The light is on. We've got all white. Well, 8 bits per channel. Let's go ahead and hit that calculator up. We know it's bits, so we'll put in the 2. We'll do the exponent, right? And then we've got 8 of them. So exponents get big fast. We have 256 possible states between on or off. That's pretty crazy. So remember when I said that the gray was like 50% on, 50% off? Well, we could do something to represent, like, if we were just only had one channel, the black and white channel here going on. Like, what would happen if we were to go in and have 255 states? Well, that would mean going from black to white. So I'm just going to take the gradient tool here, and I'm just going to touch on one edge of the screen, and I'm going to drag on over to the other edge of the screen. These are all the shades that we could get. Right in the middle, we have 50%. On one side, we have 100%. On the other side, we have 0%. Everything's off. So, well, wait, that's colors. We can look at that differently, right? So we can go right into our color picker by double-clicking on our swatch here, and that will bring it open. Hey, check this out. Whoa, wait, what's this? We've got, this is brightness, by the way, if no one said that before. We have 100% brightness. We have 0% brightness. But notice the numbers that we're getting that relate to that. 100% brightness, we have 255. And 0% brightness, we have 0 all down the line. Well, wait, shouldn't that have been 256? We just calculated that. Well, computer science, things start at 0 instead of 1. So stuff actually begins 1 over. So we can do that by just going -1. Oh, yeah, there's the 255. That's where that's coming from. So this is all some neat mathematics, but what does that really have to do with us as artists? Like, what's going on here? Well, it has to do with how RGB mixes, and then we can find out where colors are coming from. Keep in mind, this is all 8-bit. We could have more bits, but even if you go up, those additional bits, they do something a little bit different. We'll talk about that later in the semester, but for now, let's just stick with 8. So thank you, calculation, for telling us about that. But let's go ahead and see what I mean by you can make a bunch of different colors here. So let's say we were in just the red channel. If we just painted red, and like, what do I mean? Well, we've got red, green, blue, we've got mixes. So if you just painted red, one big red dot, what is one big red dot? Well, I take the sampler tool. So again, color picker, just click on your swatch. The eyedropper will show up automatically. Just click right on it. Oh, look at that. We've got red at 255. That's 100%. And we've got green at 0 and blue at 0. So it's just red. It's like as red as it can possibly make. Now this warning sign, if you've ever seen that show up before, that's just referring to the fact that it can't print that because it's a color that exists outside the range. We'll talk about that a little later in the semester as well. But if you click on it, we'll say this is really what it will look like if it goes through a printer, assuming you have everything calibrated. But you notice that it's not 255 red. That's okay. We're in computer land. Green's the same deal. Blue's the same deal. Yeah. So we've got all those guys, but we're talking about mixing, right? Like, what's going on here? So let's take a look. Let's recreate this. So these are all bits, right? So we've talked a little bit about what a bit is. So we'll come on in here. I'm going to take the black here. I'm just going to fill the whole screen. And I'm going to do that with Alt-Delete. And now we have black. So we already talked about what that means. That means everything's off. It's all 0 here. We have 0 brightness. We have 0 in red, 0 in green, 0 in blue. Okay. So we know what white is now too. It's 255. Everything's on. We're going to go ahead and take a big old brush, just B for brush. Take the big old brush here. And I'm going to go to channel instead of just clicking, which would just make white, assuming I have white active. Just make white, right? Control Z to undo. Well, if we go to just the red channel, we're going to put 255 in red, but nothing else. So that means, whoa, when we go back to our composite, we're getting the red. We're getting just the brightest possible red. And to demonstrate that that's the same, I can go in and click it. Look at that, 255 red. So I can come on in here, and if we go to green, nothing on the green channel. See that white dot? Yeah, it's only red. So if we add in green, we've now got white. That's 255. Oh, look at that. We have red and we have green. Now, unlike in subtractive color, where if you were to mix red and green, you'd actually neutralize them and get a gray. If you've ever played with crayons, you might have seen that. If you've had your color and design class, that's something they'll cover too. In additive color, it does something a little bit different. What it's actually doing is producing yellow pretty wild. Let's go ahead and look at blue. Let's add blue into the mix. Again, we're using white, but we're just clicking down here on the blue channel. Now, if we look at the composite, we made the bluest possible blue. So now we have something interesting. This is the same thing that I had earlier. We have red, green, and blue, and we have the mixtures, which are magenta, yellow, cyan. Where everything overlaps, we end up with white. Well, that kind of corresponds with what's been going on over here. That's pretty cool. So, you know, white is 255, so all three channels going on. Good. We got solid white. But I was asking, hey, what happened if we started with black? And then we went in and we didn't use all of that. So remember, we've got the option of flipping some of those switches on, some of those switches off, like a fader. If we only put it at halfway, what happens if we only do put it at halfway? So I'm going to go ahead and go to my color picker here, set it to 50% brightness, which is 127 for red, green, blue. And take my brush, just going to click right in the middle. Oh, that's a nice gray. So what's that do? Well, look at that. We've got a different kind of red. Well, what happens if we go to green? What happens if we go to blue? Well, we're going to end up with some slightly different colors because we're changing the mixture. We're changing things in. Now, this is if they're all the same. That's the same thing as if we just put a gray wash across it. But you can do more interesting stuff than that. You can go in and instead of just a solid on one of them, right? Like, what if one of them was slightly brighter? Boop. We start to get some different colors. Look at that. Instead of white, when they're all the same, they're black to white. They're just gray. But here's something a little more interesting. If you have one of these channels or two of these channels or all three of these channels as different sets of numbers, you end up with all of your different colors. That's what's going on with these color pickers. So we can slide these around. Look at that. If we just slap this right in the middle, right? As we move this around, we can see that right here on our hue. If we slide this around, we can see that our red, green, and blue are different between each other. Oh, that's a little strange. How's that really making color? What's really going on there? Well, here's another question for you, and this one's a little strange too. So if we're just adding in more light, and I'm making the claim that that light is somehow mixing differently than it would in subtractive color, where some light gets absorbed in subtractive color and the rest gets bounced back. In additive, you're just pouring in more and more light. Let's think about this differently. If you went to a movie theater and you saw a projection screen, that screen would be a fairly bright white color. In fact, on some of the newer screens, they actually have literal silver in there. Call back to the silver screen, if you will. So if someone projected a book page on the screen, you would take that white and you would add in some colors, and now you've got the book page, which is still white, like okay, and then you've got the black text. So there's the question. How are you projecting black text? The projector doesn't project black. It's just projecting colors, just like Photoshop is here. You've only got the red, green, and the blue at different intensities between the three. But what's going on? So we know now that we have different intensities for each of these three channels. Each of these channels corresponding to red, green, and blue. I've made the claim you can mix any color with this. I've made the claim that you get those colors by changing the values between the three channels. So instead of this white with the 255, you get different amounts. But how do you project black? And why are these colors? Why is that changing? Well, we'll take a look at the Colorful Notions video, and that will explain a lot about what's going on. It has to do with something called color constancy. It's pretty amazing stuff, and it has to do with pretty much everything that's going on from here. What's important to know for this video is that the channels palette is controlled under your image mode, and for this class we're going to be mostly working with RGB. There will be an assignment much later in the semester where we'll be working CMYK, and we're going to be dealing mostly with 8 bits per channel, which means that stuff maxes out at 255, and at 0 everything's just off. That's essentially what's happening when we're dealing with just the channels palette. So next on your list, let's go ahead and have you watch Colorful Notions, a PBS special that talks about color constancy. Okay, thanks for sticking with me. You have a great day.